Okay, this lesson is going to be on physical and chemical changes and properties. And because we are going to be comparing and contrasting these things, I want you to draw a Venn diagram on your page. So your Venn diagram should look like this. The left-hand side is going to be our physical. The right-hand side is going to be our chemical. And then I also want you to divide your Venn diagram like this. And the top half of our page is going to be for properties. Okay, so top left corner is physical properties, top right corner is chemical properties. And then the bottom half of the page is going to be for changes. So for example, bottom left-hand corner is going to be physical changes, bottom right-hand corner is going to be chemical changes. Okay, so some physical properties are that they are observed with the senses. So you see it, you smell it, things like that. Physical properties are determined without destroying the object. And it also does not change it into a new substance. Or does not change it into something new. In the Venn diagram, I'm going to put some examples. Okay, so the top half of this circle on the left-hand side is my physical properties, and some properties include color, density, odor or smell, melting point and boiling point, mass, volume, and viscosity. So those are all examples of physical properties. So if I'm describing the color of something or the smell of something, that's considered a physical property. Now a physical change, on the other hand, so now we're on the bottom, for example, would be tearing, cutting, bending, another would be diluting, and dissolving. Also, and I'm going to put a star next to this because it's really important, all phase changes. Are physical changes. Okay, they're not chemical, they're physical. Phase changes means, for example, when you're going from a solid to a liquid, so like melting, evaporating, freezing. Those are all phase changes. So those are physical changes because it doesn't make something new. And just to clarify what changes are, this is the change. Does not result in a new substance. So if you tear a piece of paper, it does not make it into a new substance. So that is why it is a physical change. Okay, now let's move to the top right corner of the Venn diagram. This is looking at chemical properties. And to define that, we are going to write that it is how something reacts with something else. I didn't leave myself enough room. Okay, so chemical property is how something reacts with something else. For example, so inside now we're going to write flammability. Which means how likely it is to start on fire. Ability to rust. So when something rusts, or if it is able to rust, that is a chemical property. And then also reactivity. So how reactive is something? If we mix things together, how likely is it to react? Those are considered chemical properties. Chemical changes now are going to be like burning, rusting, explosions, mixing chemicals, rotting or decay, digesting food, and also cooking food. All right, those are all examples in which a chemical change occurs. So a chemical change, I'm going to define it on the bottom here. It produces a new kind of matter or a new substance. And because it is a chemical change, what actually is happening at a deeper level is that bonds are breaking. And new bonds are being formed. Okay, so we have physical properties, we have chemical properties, we have physical changes and chemical changes. Now there's just a couple things that go in the middle of this Venn diagram, and that is something that can be either physical or chemical depending on what causes it. For example, color change or bubbles. All right. Color change, if you are dyeing something, so if you're adding food coloring, that does not make a new substance, so that would be physical. However, if you mix two chemicals and the result of those two chemicals mixing is a color change, that would be chemical. With bubbles, if it is a gas-producing bubble, then it's chemical, so I'm going to write that in. If it is gas producing, then it's chemical. If it is because of boiling water, then it is physical. So we said all phase changes are physical, so if you have bubbles because you're boiling water, that's considered physical. However, if you mix two chemicals or mix a couple things together and it's producing a new gas, then it's chemical. So that's why those two things are in the middle. All right, I have a diagram here just to show you some pictures of things that are physical changes and chemical changes. So first on the left-hand side, lighting a match. Okay, that's burning something. Anytime you're burning something, it's going to be chemical. We said explosions. Oops, I wrote over that. So fireworks, exploding, fire, lighting things, that's going to always be chemical. Rusting. Rusting is always going to be chemical because oxygen is reacting with iron to form rust. And so anytime you see that word reacting, that's going to tell you that it's chemical. We said digesting food. Okay, it's breaking bonds. It's making new things. Vinegar, this is spelled wrong, but it makes milk curdle and forms a solid, so it's making something new. It's going to be chemical. An instant cold pack, this is a type of reaction. And so even if you don't know what these words mean here, the word reacts tells you that it is chemical. Heat is created. Okay, and so if you look closely, and it's pretty blurry, but it's telling you that things are being mixed and that they're reacting, so that tells you that it's chemical. Okay. Oops. If we look over to the physical side, you'll notice that it's a lot of things that you see. Appearance of something, folding a paper. Okay, folding a paper, the paper is still the same thing. It's just different, it's a different shape. Volume of something, malleability, or if something's malleable, so if you can pound it down to a thin sheet, you're not changing the substance into something new. Always phase changes, so melting, dissolving, you're not making a new substance. When water boils, it's still water. Okay, the color of something, density, flexibility, those are all physical changes. All right, the last thing that we need to define is the difference between intensive and extensive properties. I talked a little bit about intensive property in the density video, and so now we're going to define it again. So intensive property is a property that does not depend on the amount of substance. Okay, some examples of intensive properties are temperature, density, and this one's almost always going to be asked, magnetism, hardness, viscosity, odor or smell, and then melting point and boiling point. So what it means by it does not depend on the amount of substance is, let's think about smell real quick. Okay, if you have a banana, it's a really bad banana, but if you have a banana, it's going to smell like a banana whether you have a little piece of it or whether you have the whole thing. Okay, so it does not depend on the amount that you have. Its property is an intensive property. Also, let's look at boiling point. For example, water is always going to boil at 100 degrees Celsius. If you have a little bit of water or you have a lot, it has to reach 100 degrees before it boils. The time it takes to get it to boil may vary, but we are looking at the boiling point so that the temperature at which it boils is an intensive property. It does not depend on the amount of substance that you have. An extensive property is something that does depend on the amount of substance. So for example, mass, volume, length, number of particles, so those are all, if you notice, those are all like measurements. And so you can kind of remember extensive properties. It does depend on the amount of substance. You can also remember it as it's usually going to be measurements. Okay, now I'm not going to say every single time, but usually the measurements are extensive properties. The mass of something, how much it weighs, that's going to vary depending on how much you have. So the biggest one to remember here is that density, well, they're all important, but density is an intensive property. It doesn't depend on the amount that you have. So if you look back, refresh at that density video, I kind of drew that in a diagram, but this is a huge one that people usually miss, just because this is a measurement. And it is a calculation. So don't think that just because it's a calculation that it's going to be extensive. All right, density is always an intensive property.